Hey, Bio20s, I just want to come at you with another review sheet from your notes. So we're going to go to the chart that is sideways in your notes. Mine's not, so hopefully you can follow along as we go. It looks a little something like this to start with. So you can see along the side here that it's broken down into mouth, stomach, and small intestine, all the different areas that we're going to see chemical digestion occur. What I want to quickly talk about is what's happening in the mouth. So here it is. The polysaccharide or starch is being broken down by salivary amylase into a disaccharide, such as maltose. So you can kind of see how this is going to lay out. I'm going to talk about what macromolecule is being broken down by which enzyme in which area of the body. I'm going to go through carbs, then proteins, then fats, then nucleic acids. All right, this is a very similar structure to the other review we've done. I just wanted to show you another version of it. The review I will post earlier, and everything else is a good way to help you study for your final assessment, which will be coming to you on Tuesday. So in our mouth, we have the salivary amylase being secreted by the salivary glands. It's breaking polysaccharides into disaccharides. Then what you're going to see, I'm just going to pull this down a little bit, is the digestion that occurs in the small intestine. So in the small intestine, I'm going to just see if I can fix my screen here. There we go. In the small intestine, you have the disaccharide maltose being broken down by carbohydrates. Now, if this wasn't maltose, if it was sucrose or lactose, they would be broken down by other carbohydrates. But in this case, it's maltose, so we're using maltase to break it down into the monosaccharide of glucose. So this is the process that carbs take through your body. All right. Proteins, nothing happens in your mouth. Not a single thing occurs. Okay. But then we hit the stomach. And in the stomach, you have a couple of things going on. Your polypeptide, such as something like a hamburger, okay, is broken down by pepsin and HCl. So HCl is a helper molecule, a helper, and not enzyme, but a helper essentially. Its job is to loosen the polypeptide. Pepsin's job is to break it into a smaller polypeptide, a little bit of a shorter amino acid chain. That polypeptide is then taken into the small intestine, where from the pancreas, trypsin and chymotrypsin are released. And it takes that smaller polypeptide and breaks it down into dipeptides. That dipeptide is now in the small intestine, and the small intestine secretes from its intestinal walls peptidases. Oh, sorry, that's a lie. Peptidases are still coming from your pancreas. Okay, the pancreas secretes it, and then you're given amino acids. All right. We're now looking here at fats. So again, nothing happens in the mouth. Nothing happens in the stomach. We're only in the small intestine. So we have those triglycerides, both saturated and unsaturated fats. For reminding yourself what is the difference, okay? The liver will secrete bile, and bile just emulsifies those fats. So it attaches to itself, creating a larger surface area for it to bind. Those emulsified fats are hanging around in your small intestine, in which pancreatic lipase, coming from the pancreas, comes and breaks it down into 3 fatty acids and 1 glycerol to be taken in to the lymphatic system. Reminding yourself, glucose or any monosaccharide and any amino acid will be taken into the bloodstream. Fatty acids and glycerols are taken up into the lymph. The last one, again, not super important as we don't talk about it as much, but we do include it here, is what happens with nucleic acids. So DNA or nucleic acids are broken down by nucleases into nucleotides. Again, nucleotides are a phosphate, sugar, and nitrogenous base bound together. While in the small intestine, we have nucleosidases released by the intestinal wall, and it breaks it into a free phosphate to be used at, let's say, converting ADP to ATP, and a nucleoside. A nucleoside is still the sugar and the nitrogenous base attached. So this is what the chart looks like. It kind of gives you an overview of everything that's occurring in the digestive system, what enzymes are being broken down, what food is being broken down by certain enzymes in certain places. So fill this in your notes, and we will get started on our assignment soon.